So this is the start of my algorithmic problem solving series. So in this first video, we'll dive into the fundamentals of problem solving and the various problem solving methods, explaining the 4 basic techniques. There's brute force, greedy, divide and conquer, and dynamic programming, where by understanding these methods, we can provide a strong foundation for tackling other algorithm problems in the future and understanding how we can break apart bigger problems into these simpler techniques. So let's get started. So in our first technique, this is the most basic of them, and this is what is called brute force. So this is generally used when we cannot find a better solution. And in the brute force solution, what we do is find every possible answer, and then we choose our correct one. Usually this is not the right answer. This is only for the right answer for these like super difficult questions, which are labeled as NP hard. And these are things like finding longest path. So we'll get back to this in later videos, but right now we just know the general idea. Brute force, find every possible answer. And then choose the correct one. The next one is the greedy method. So greedy. So in the greedy method, what we do is we always make the locally optimal choice. Optimal choice. Basically saying we have no recollection of the past and we don't do any computation to say, hey, how will the future be? We just say at this state, what is the best thing to do to get to our solution? So a quick example of this is, let's say we have a big box, right? And in this box, we have some prizes. So we have with values. So we have one of value 14, one of 12, one of 1, 6, 5, and 2, right? And we want to figure out a way so we can choose only 2 items in this box, and we want to maximize the value of what we get. Well, you can do this as the brute force kind of way, saying every possible combination of 2, see which combination of 2 has the highest value, and then that's our solution, right? But we're doing a lot of unnecessary calculations. In greedy, we can make the locally optimal choice, where first we have all our items and we sort them. 14, 12, 6, 5, 2, and 1. And if you want to choose the 2 items that maximize our solution, so make this a different color, 2 items that maximize the solution, well, we'll do what, like, I guess general problem solving tells us. First, choose the best one, 14. In our second item, we choose 12. So here, we're choosing the locally maximum solution, being our locally optimal choice, and therefore, this is kind of a greedy method to solving this question. The next solution is what is known as divide and conquer. So divide and conquer. So the divide and conquer method involves taking some larger problems. So we have some big problem. We divide these into various subproblems. And by solving each of these subproblems, we can then reconstruct and find a solution for our larger problem. So an example of this, just a simple kind of example, is if we have an array of numbers. So we have an array of 5, 14, 3, 6, 17, 2. Divide and conquer says, okay, split up our array. So we have 5, 14, and 3, and we have 6, 17, and 2. We solve our left subproblem, so it means our max value is 14 here. We find our right subproblem, our max value is 17, and we combine our solutions saying, okay, what is the max of these? 17, meaning that is the max of our entire array, hence our solution for the big problem. And one thing to note in divide and conquer, it doesn't need to be 2 subproblems. We can divide it into sum n, we could divide it into 20. Well, here we have 6, so it could divide into 6, and so on. And now our third and final kind of technique is what is known as dynamic programming. Also kind of said as DP. It's just a shorthand way. So in dynamic programming, it involves breaking down a problem into overlapping subproblems, and then solving these subproblems that we can then use as a way to solve our, larger problem. This is slightly different than divide and conquer, and I'll show that through an example. So in divide and conquer, we have like a larger problem that we split apart. In dynamic programming, we use the example of the Fibonacci sequence. So the Fibonacci sequence goes 1, 1, 2, 3, and then 5. Where basically what I'm saying is the Fibonacci value of some n is equal to the Fibonacci value of nth minus 1 plus the Fibonacci value of the nth minus 2. Now, this is recursion because to find this value, I'm recalling the function on these smaller subproblems, right? So we can solve this using recursion, right? But the issue with that is to find the fifth, we have to find the fourth and third. Then to find the fourth, we find the third and second. To find the third now, we do second and first. Second and first. But we're recalculating a ton of values. Recalculating the third twice, the second 3 times, and the first value twice. That takes too much of our runtime. So we can use dynamic programming to store these values in an array. And so solve this better. Let's say we're trying to find the fifth Fibonacci number, so the same as the array. So 1, 2, 3, 4, and 5. This is 0, the next 1, 2, 3, and 4. So this will hold fib of 1, this will hold fib of 2, and so on. So here we know the first Fibonacci number is 1, second Fibonacci number is 1. Second then looks at the index before it and the index before that, adds them up, so that's 2. The third looks at the index before it, before that, 3, and then 4 looks at the index before it, and then before that, it's 5. What we're basically doing is solving the subproblems and working our way to our actual solution, where we know our solution is 5. So this is how dynamic programming can help us. So what we did here is look at the 4 basic problem-solving techniques: brute force, greedy, divide and conquer, and dynamic programming. Where brute force involves finding every possible combination of answers and then choosing the one that solves our problem. Greedy involves doing the locally optimal solution. Divide and conquer involves taking our big problem, breaking it down into identical subproblems, and by solving those subproblems, we can reconstruct our answer for the big problem. And then dynamic programming, which involves solving these subproblems and working our way to the larger problem. And so by understanding these 4, in later videos you'll have a better idea of when we choose these various algorithms for different questions, understanding the runtime, understanding how we can use these algorithms, and figuring out how we can prove that what we did is the best algorithm. Alright, I'll see you in another video, and goodbye.